and welcome. My name is Jennifer Gates, Field Services Director for the California Preservation Foundation. The California Preservation Foundation is a membership-based, not-for-profit organization whose mission is to provide statewide leadership in education and advocacy to ensure protection of historic resources in California. We want to thank you for joining today's webinar on industrial archaeology, roads, bridges, manufacturing, and more, and encourage you to become a member of CPF and enjoy the benefits and educational discounts. Information on membership can be found on our website. The format for today's webinar will include a presentation followed by time for questions and answers. There is a toolbar on the right side of your screen. If you have a question at any time during the presentation, please type it in the box and we will hold the question until the end for the presenters to answer. You will be muted throughout the presentation. To hide or unhide this toolbar, click on the orange arrow. Please adjust your volume on your computer or phone. Today's presentation will be by Patrick Martin, Stephen Meixell, and Marissa Mosher. After a peripatetic childhood as a military brat living in several states and countries, Patrick Martin earned a BA at Miami University, an MA at University of Arkansas, and a PhD at Michigan State University, all in anthropology. Specializing in archaeology, Martin has studied mines, mills, and workers' communities in Michigan, New York, California, Alaska, the U.S. Virgin Islands, and Norway. Architect of the graduate program in industrial archaeology at Michigan Technological University, he served the Society for Industrial Archaeology as editor and executive secretary and is currently the president of the International Committee for the Conservation of the Industrial Heritage, as well as professor of archaeology and department chair of social sciences at Michigan Technological University. Stephen Meixell is a principal and senior architectural historian with ICF International, a consulting firm specializing in environmental planning and natural resources. Mr. Meixell was the Deputy State Historic Preservation Officer in California from 2001 to 2010. Prior to that, he was a partner in JRP Historical Consulting Services. He has also worked at Caltrans, where he wrote the book Historic Highway Bridges of California. Mr. Meixell's experience includes managing complex survey and evaluation studies and handling the most complex Section 106 compliance efforts. At ICF International, he is managing large consultation efforts in New Mexico, Washington State, and Ohio. He is especially experienced in managing large contextual studies, having prepared book-length analytical tools for historic bridges and military properties in California. He received a BA in History from Harvard University and an MA in History from the University of California, Davis. Marissa Mosher holds a MS in Historic Preservation from the University of Pennsylvania and a dual BA in Art History and French from Wellesley College. With 2 years of historic preservation experience at Chattel, her credentials include meeting the Secretary of Interior's professional qualification standards in architectural history. Her work spans several areas of historic preservation, including preservation planning. At Chattel, Marissa has conducted historic resource surveys, written historic context statements, and prepared historic resource assessments for purposes of environmental review. For Survey LA, a comprehensive citywide historic resources survey managed by the Los Angeles Office of Historic Resources, she authored sections of the historic context statement on industrial development related to automobile manufacturing and agriculture. Her other experience includes working in museum education, exhibit research and design, and historic site interpretation at places as diverse as the Louvre in Paris, France, and the Woodlands, a mid-19th century cemetery in Philadelphia, Pennsylvania. Thank you for joining us today.
Thank you, Jennifer. This is Pat Martin. Welcome. I'd like to start today by putting up the first slide, but it doesn't seem to want to appear.
Oh, it's there.
It is. Good. Now I've done that. I'll back up. The term industrial archaeology was first articulated in print by a Portuguese scholar named Viterbo in 1896 as part of a recognition that museums and the public acknowledged careful study and protection of a variety of ancient monuments and folk traditions but should also perhaps give some systematic attention to the relics of early industry. Nearly 60 years passed before a serious rebirth of the term in the English-speaking world in the context of preservation conflicts in England, centered on the destruction of symbols of England's glorious industrial past. One particular battle concerned the elaborate portico of the Euston Station in London, a struggle that galvanized citizens and indirectly led to a flurry of writing and organization around the theme of industrial archaeology. Another significant development during this period in the 1960s was the creation of the Iron Bridge Gorge museum system in Shropshire, centered on the world's first cast iron bridge dating from 1779, a site ultimately inscribed on the World Heritage List. This preservation initiative was initially focused on standing structures and soon moved to the listing of, quote, monuments equivalent of castles and Roman roads into the National Registration System. As early as 1955, the term was used in a publication known as the Amateur Historian, and by 1958, an Industrial Archaeology Research Committee had been created within the Council of British Archaeology, or CBA. A national record of industrial monuments was compiled, to a great extent with the help of interested amateurs, and this new field of study was seriously launched with a number of publications and activities through the 1960s. Out of this grew several regional societies that ultimately affiliated into a national group called the Association for Industrial Archaeology in 1973. While the first impulses were focused on preservation and mostly involved above-ground resources, the use of the term archaeology was justified on two key grounds. First, it seems that the CBA, the Council for British Archaeology, was a key entity for gaining support of systematic registration of sites. And second, perhaps more important, was the recognition that the term archaeology denoted and signified a concentration on the material evidence, the things and places, rather than just the documentary evidence and or ideas of history. It's this sense that continues in practice today in much of the world. Industrial archaeology, or IA, is not necessarily about traditional archaeological practices, but rather is focused on the material remains of industrialization. It may derive from an archaeological perspective, an historical perspective, a museum's perspective, a planning and management perspective, or even the perspective of an informed avocational enthusiast. But all these perspectives come down to IA. Industrial archaeology, then, is the systematic, disciplined study of the processes and products of industrialization, as well as the organized efforts to preserve and interpret those remains for the future. In this latter role, we often also see the term industrial heritage applied, rather than just archaeology. IA in the U.S. The establishment of IA in the UK influenced its adoption in the U.S., primarily through direct contacts among practitioners. I tried to move a slide, but I'm waiting. There was some lively interaction during the late 60s as international groups convened to share insights and experiences. Of particular importance to the development of IA in the USA was Robert Vogel, curator of mechanical and civil engineering at the Smithsonian Institution's Museum of American History. Jennifer, I'm failing to make that slide move.
Try it one more time with your mouse.
Over here.
Mm-hmm. Thank you.
Vogel is the character to the right there next to the young lady. Vogel's interaction with English colleagues in the American Society of Civil Engineers combined with his interests in early American industry and to a great extent resulted in the formation of the Historic American Engineering Record, or HARE, within the National Park Service in 1969. This led to several survey initiatives, particularly focused on the milling districts of the northeastern U.S., and the establishment of a set of methodologies and standards that persist to this day. We all know them as HARE standards and guidelines, available on that HARE website. HARE continues to build a massive database of survey and documentation data housed in the Library of Congress and accessible on the Library of Congress website under a collection that includes HARE, HABS, that is the Historic American Building Survey, and the Historic American Landscape Survey documents. These extensive materials constitute a significant research resource accumulated over decades of professional work. It's no accident that the Society for Industrial Archaeology was founded with substantial involvement from Vogel and others in 1971. This followed closely on the heels of the creation of the Society for Historical Archaeology, or SHA, in 1967, and many of you know about SHA, I suspect. There was serious consideration of simply creating an affiliate of the SHA, but the perceived differences between the two groups, particularly the matter of an SIA focus on preservation and a focus that did not involve digging for one's data, led to the creation of a separate society. Note, as an odd aside, the separation is signified in the spelling of archaeology, with SIA siding with the National Park Service practice in eschewing the second A. Notice here. The SIA has been a core organization for both scholarship and preservation advocacy regarding industrial heritage in North America since its founding. With membership ranging up to about 2,000 at times, it includes primarily individuals, many of them enthusiasts rather than people who make a living in the field. We reckon that this is a vital element of the SIA, bringing together practitioners and the interested public in an integral way that cross-fertilizes the field. Retired engineers, railroad hobbyists, canal enthusiasts mingle with academics, museum curators, and government heritage experts in ways that benefit all of those involved, as well as focusing attention on critical sites and landscapes. SIA publishes a peer-reviewed journal, a quarterly newsletter, and holds at least 2 conferences a year. The bulk of our publications are available online, and we include some excellent technical aids, including lots of stuff, particularly about historic bridges. Find the SIA on the web at www.sia-web.org. In addition to these national groups, like the AIA and the SIA, there's an international organization that serves to connect constituents on a global level and to articulate their interests to larger entities such as UNESCO. The International Committee for the Conservation of the Industrial Heritage, or TICI, began formation in 1973 and has grown in both size and influence over time. With representatives from over 40 nations, TICI holds major conferences at least every 3 years, with thematic meetings in intervening years. Publishes a quarterly bulletin, and the buttons are not coming up. Oh, there we go. And has recently published an international best practices book entitled Industrial Heritage Retooled. By the way, you notice the California cover on this international guide. That's the rehabbed Ford plant at Richmond. TICI has also served, since sealing an agreement in 2000, TICI has also served as a scientific committee for the International Council on Monuments and Sites, that is ICOMOS, providing expert advice on World Heritage nominations for industrial heritage sites, and has recently generated a joint principles statement, seen in the left side of the screen here, known as the Dublin Principles, that articulates advice for operations on a state-by-state or country-by-country basis. So why is industrial heritage relevant, you might ask? Industrialization is a central feature of the continuing evolution of human society. Perhaps, and I would argue, the most important of all in terms of its impact on humanity and the environment since the agricultural revolution. The rise of an industrial mode of production out of a pre-existing agricultural base transformed and continues to transform the relationships of people to one another in terms of how things are made and distributed, the scale at which we modify the earth and the atmosphere. And it drove the process of urbanization that characterizes the modern world. Landscapes based on industrialization define the existing patterns of urban development and the transportation links that connect populations. Understanding industrialization is essential to understanding modern humans, and preservation of some physical aspects of this process is a potentially important element of the unfolding emergence of new structures of work and life in a deindustrializing world. IA must consider the processes of production and the workplace, not just machines and technology. IA must include not only descriptive understanding of industry, but also should strive to provide explanation and analysis of the system, the complex internal relationships between people, organizations, and environment in an industrial context. And IA must consider the preservation and interpretation of these resources too. IA has a complex role that includes both scholarly and practical dimensions, with participants involved in both intellectual and compliance activities. And I'd like to leave you here with a little discussion of a case study. While historians, architects, whoops, I got two, back up. While historians, architects, engineers, and planners handle much of the work in IA, there is a critical role for traditional archaeology as well. And a number of us self-identify as archaeologists. I'm one of those. And I want to give you a little brief view of an active project that exemplifies IA in current practice. The West Point Foundry in Cold Spring, New York, was one of America's foremost early industrial establishments. Located on the Hudson about 50 miles north of New York City, directly across from the U.S. Military Academy, this heavy ironworks opened in 1817 as a key part of the national effort to institute a new system of ordnance manufacturers spatially spread around the country to avoid a repeat of the unfortunate destruction of cannon-making capabilities suffered when the British burned the Georgetown foundry in the War of 1812. The West Point Foundry Association, and I give you just this crude timeline to consider, the West Point Foundry Association was a group of well-connected partners that enjoyed a strong relationship with the government and a steady stream of substantial contracts during the foundry's nearly 100 years of operation. While they also produced a wide range of heavy iron products such as steam engines, several of America's earliest locomotives, cast iron architectural parts, and sugar mills, they made their reputation as a considerable share of their income from the manufacture of cannon and shot. They began making other gun types, but this foundry became the home of the Parrott gun, a rifled cannon and its projectile that were patented by the foundry superintendent Robert Parrott in 1861. Widely used by Union forces in the American Civil War and credited by some military historians as a key element that allowed the victory of the Union side. Following the war, demand for the foundry's traditional cast iron products waned, the original managers retired, and operations slowed to a stop by 1912. A succession of smaller firms used the space, but it was gradually abandoned until only one ruined structure stood on the nearly 100-acre parcel in the late years of the century. In 1996, the foundry property was acquired by the Scenic Hudson Land Trust as part of its mission to protect open green spaces in the Hudson Valley. Located on the river, adjacent to both the village of Cold Spring and a parcel protected by another environmental organization, this property is a key element for local preservation. The industrial heritage character of the place was a secondary consideration to the new owners, but was embraced enthusiastically once they came to appreciate the unique importance of the place. In 2001, Scenic Hudson approached me and the IA program at Michigan Tech to develop a research project that would explore the site with an eye to providing information to support an interpretive program. Over the next several years, MTU students, faculty, and volunteers conducted historical and archaeological research focused on key portions of the sites. Traditional excavation and analytical techniques offered significant insights into critical factors of operation, change over time, production details, environmental conditions, and a host of matters not fully described or explained in the fairly copious documents left by this operation. I'll examine just a couple of these insights for you today. The initial forays into the West Point Foundry research involved intensive mapping of visible surface remains. While only one structure actually stood within the 100 acres, the foundations of many other buildings were evident on or just below the surface in the wooded area that contained the foundry. Mapping those remnants and overlaying them within a geographic information system that also included a series of historic maps allowed the team to work out a sequence of construction for the site and target areas where remains were not so readily accessible or visible. And this is an example of one of the historic maps and the area of the foundry shown here. Collecting spatial information in a digital format using a laser-based total station allowed the team to enter data into the GIS in a way that supports an extensive array of manipulation and analytical capabilities. Overlaying the historic maps on the existing conditions allows us to portray both the visible and invisible former features of the landscape, providing a rich perspective for understanding change and development over time. Working from this system of maps, we were able to focus attention on topics such as the largely buried water power system, partly shown here, the workers' housing, the boring mill and casting house, and a technological shift from charcoal to coke in iron smelting. The West Point Foundry was established on Foundry Brook, a small but reliable source of water power. And here you've got a plan at the bottom showing the brook and several dams, such as here and here. And at the top, you see a cross-section that shows the change in elevation down this valley and some of the key locations, such as this 36-foot diameter water wheel. Because all of the foundry's operations were powered by water, the control and efficient use of this falling water was essential. In order to manage it, the company built a series of dams and raceways to store and channel the water. While the dams are obvious, several of the raceways are obscured, both by degradation of the landscape and the fact that they were buried from the outset. For example, a blast furnace located just below the largest dam in this area with a water-powered blowing engine was quite evident. We're fortunate also to have access to some contemporary images that show, for instance, the relationship of the furnace, and the dam, and the blowing engine. This is a drawing from 1832. A marvelous piece of evidence to help us interpret this fairly complex site. However, examination of the site itself revealed some complications. For instance, a small waterway entering the area of the blast furnace upstream and exiting below the blast furnace. Excavation disclosed a channel leading from the stream passing beneath the furnace. And here you see an opening. This is the channel, and this is the area of the blowing engine with the furnace mound in the background. This arrangement runs absolutely counter to the most reasoned advice about blast furnace operation, and by the way, counter to a lot of what the diagrams and documents show us. Purposefully passing water near the intensely heated masonry mass of a furnace invites disaster. However, the physical evidence is irrefutable and is reinforced by this early 20th century photograph that shows the remnant of that channel leading under the furnace full of water. Here's a modern photograph of the same area. Notice the little person sitting in this one and in this one for scale. Okay. Subsequent analysis suggests that this arrangement reflects a careful management of resources, allowing the wastewater from the blowing engine wheel to be combined with water from below the dam and to be reused in the boring mill further down the valley. It's actually a reasonable calculation. From the storage pond, water was fed through an open head race into the boring mill, where it exited off a 36-foot diameter water wheel and flowed back to the Foundry Brook. But the opening at Foundry Brook was not evident immediately. The detailed topographic survey of the ground surface in the GIS revealed that the input to the tail race was actually at an elevation below the stream bed at its nearest point, making it impossible to drain the water from the mill directly in a straight line. After excavating the wheel pit, you see it here, opening the tail race and pumping down the groundwater, we deployed a remotely operated submersible vehicle and attempted to trace the tail race path. And you see some of the images below. After negotiating some turns and 50 feet of passage, we were blocked by root growth. But meanwhile, we engaged some remote sensing. In this instance, using ground-penetrating radar. GPR is an electronic technique that projects electrical impulses into the ground and carefully measures the reflected signals to identify and locate buried objects, soil layers, and disturbances. The GPR identified anomalies that proved through excavation and observation to expose the nearly 600-foot-long path of this buried tail race, something we never could have done without it. Coupled with limited testing, also allowed us to identify the extent and locations of a series of buried drains, such as this one here in the lower right. These virtual views of underground features, followed by excavation, provided significant insights into the structural nature of this ruined and largely obscured industrial complex. Insights that were simply not possible through the documentary record. In addition to these and many other research questions answered by excavation, this set of techniques has two additional fairly powerful benefits. First, the process of excavation is an excellent tool for public interpretation. Visitors love to witness discovery in real time. For instance, this painting, which resides in a local museum called the Gun Foundry, depicts the process of casting cannon. And you'll notice there are two casting pits here outlined in brick. Our various kinds of survey and excavation remote sensing allowed us to expose, to discover in a deeply buried context one of those casting pits. And the very discovery of this brought hundreds of people out to witness what was going on our site. Second, this work is a classic case in point for that kind of phenomenon where at open house weekends, in the beginning and the end of the season, hundreds of local people and citizens from the region visit us daily, fascinated and delighted at the progress. Many people expressed amazement that archaeology, a discipline that relates in their minds to the ancient past, could reveal so much about events of a more recent time and about industrial activities that lay buried beneath their feet. While historical research takes place in an archive or an office, the active process of excavation opens a window to the research enterprise that is compelling for the public as they seek to understand the background of the industrial past. The second benefit offered by this kind of excavation is that we simply expose the physical evidence for interpretation. These remains that you're seeing here, the base of a cupola furnace, are at this very moment being incorporated into an interpretive development of this site for the public and for perpetuity. While simply exposing things is a little more passive than the dramatic and dynamic excavation process itself, revealing these otherwise invisible features is an important part of archaeological research. In sum, I want to say that IA, and particularly the archaeological practice of IA, employs a powerful set of techniques and perspectives that work in the realm of compliance and in scholarship, both in enlightenment and in preservation. And I urge you to embrace those techniques seriously in the future in your own work. I put this slide up, and including some active links, to give you some connections with some important and potentially useful resources, websites, and publications. And I want to point out for the California folks in particular, this bottom piece by your own Matt Roth, a fantastic article entitled IA in the 20th Century City, Who Will Love the Alameda Corridor? I encourage you to read it if you can. And let me leave you then with one more image and a couple more websites. And thank you very much for your attention.
Well, that was most interesting, Pat. I enjoyed it a lot. This is Steve Mikesell, and I'm going to be talking to you about one class of industrial archaeological properties, those associated with transportation systems, and specifically transportation in California, which is where I've done the bulk of my work. Transportation has always been enormously important in California because it was such an isolated place, and in many ways still is. So transportation resources are important. Transportation systems are heavily used and must be upgraded on a regular basis, so that it's very rare to find transportation systems or even individual resources that retain their historic appearance. There's an old line that says that the transportation system that isn't maintained is a transportation system that doesn't exist. So you tend to find transportation resources in isolation rather than in full systems. And I'll illustrate this. And there are two types of those resources that I maintain will be preserved. First, things that were inherently well built for heavy use, and bridges being the best example of those, or things that were built to a degree of beauty that were designed for marketing purposes, with train depots being the most common example of that. And I'll illustrate those 2 points by focusing on 5 types of transportation resources that are in roughly chronological order: waterborne transportation, railroads, transit, highway, and airports. I hope I have the better luck than. There we go. Waterborne transportation included ships that went to the major ports, as well as river boats that carried goods and people from San Francisco in the earliest years up to ports like Marysville and Sacramento. There's very little that is left of those transportation systems, and one of the really fantastic examples of that is the ferry building in San Francisco, which I think falls into that second category of resources, things that were built to a very high architectural standard for the purpose of branding, for the purpose of branding both the city of San Francisco as well as the ferry systems that used this building. The second system is railroads. Railroads were primarily built around rails and ties, essentially none of which last more than 10 years, 20 years. So what remains are the very well-built resources like bridges, and what we're looking at here is the I Street Bridge in Sacramento, which shows another interesting fact that transportation systems interact with each other. This bridge carries automobiles and trucks on the top part of the truss, and then carries trains on the second part, and of course on the bottom part of the truss, and of course it opens up to allow riverboat transportation go through this. It's a well-built, this thing is built in 1901, as I recall, and is still very much a functional part of the main old Southern Pacific line between San Francisco and Chicago. Equally durable are things like depots, and this is the Sacramento depot. It's about a block away from the I Street Bridge. And I would say that it illustrates a kind of a marketing. I mean, it was built to last and was built to be looked at as a part of the marketing program of the Southern Pacific Railroad. It also is still used as, it illustrates a different kind of interconnection of transportation systems. This has, you can't really see it here, but it had a streetcar pull out in front of the building, and it does to this day. The only real difference is that the streetcars move to the back of the building instead of the front of the building. Another type of railroad resource is a industrial railroad. This is called the Mountain Quarry Bridge it's Placer County on one side and El Dorado County on the other side, and it was built to carry an industrial quarry railroad. It's one of the most photographed bridges in California, in part because of the stupendous setting this, and also because of it's just a very graceful, handsome bridge. Transit systems left even fewer resources behind because the level of durability wasn't the same as it is with railroads. You do have some. This is the Tower Bridge in Sacramento, which is about 3 blocks away from the I Street Bridge, and you can see this from the 60s, I suspect, when it still had the Sacramento Northern electrified transit system running down the middle of it, as well as having cars running both directions on the outside of that. Otherwise, there's very little that remains from transit systems. This is a really lovely resource. It's actually designed by the architect Green & Green in Pasadena. On the left is a waiting station, and on the right is a bridge going over transit tracks. The next branch of transportation that we can talk about, of course, is the highways, which is what you're probably most familiar with. That's our principal mode of transportation today. Bridges are the most durable and in many cases the most beautiful parts of the highway transportation system. This is a roughly 1915 view of a bridge, probably just shortly after it was built. And this bridge is still in use and still exists. It still looks almost exactly the way it does in this picture. This is going across the Tuolumne River in downtown Modesto. Nice bridge. Other durable resources include retaining walls, which include tunnels. This is the Stockton Street Tunnel in San Francisco, which has some literary merit in the sense that this was the location where Miles Archer was popped in the Maltese Falcon. You have to read the book; this is true. And another durable element of the highway system is retaining walls. You don't think much about them, but they're built to last, and they're really very lovely to look at. This is right at Echo Summit, headed down to Lake Tahoe on US 50, and you can see this. The Caltrans did a wonderful job of retaining the original stone masonry aspects of the retaining wall while building a big concrete wall behind it, and the structure looks very much the way it does today as it did before this repair work was done. Caltrans has done some really excellent work here and there. Final line of mode of transportation is airports, and I think that there are fewer airport resources left than anything else because of the constant change in the technology. And this is what I would call more along the line of a marketing building. It didn't have to be built this beautiful. It was built this beautiful to market the city of LA and LAX in general. And then this is the best looking airport resource that I've ever run across. This is the main terminal at Santa Barbara. So even though transportation resources tend to be found only in isolation, here and there it has been possible to preserve an entire system so that you get the feel of the entire system as well as the function of the entire system. So the question is, how do we retain historic character of a system while providing necessary maintenance? And I guess the answer really should have been very carefully, or it's extremely difficult and it's extremely rare. And I will give you two case studies, one that has been completed and has been highly successful, and that is the preservation of the Arroyo Seco Parkway. The Arroyo Seco, or what's now generally called the Pasadena Freeway, is one of the most important highways in the United States. The Californians say that it was the first freeway. People in New York disagree with that, but it's certainly one of the first true freeways to be built in the United States. And it was really a lovely piece of engineering as well as a lovely piece of architecture as well as a piece of engineering. In the last decade or so, Caltrans realized that it needed, the California Department of Transportation realized that it needed to fundamentally upgrade this facility, from repaving to work on the bridges to the retaining walls, the entire system. Because it had been designated, has been listed in the National Register, Caltrans decided to do the right thing and to rehabilitate it consistent with the original design of the resource. The original design included the early bridges, which were built by the city of Los Angeles, which had a long tradition of making very sturdy and beautiful bridges. And basically, the bridges that you see in Los Angeles look like this, and the bridges that you see, and they were designed by the city, the bridges that you see in Pasadena were designed by, a little later, by the Division of Highways, or the predecessor of Caltrans. And the engineers mimicked these very much after the bridges in the Autobahn in Germany. And they have, even though this bridge goes, is now 60 or more years old, it feels very modern because it was very much the prototype for modern freeway overcrossings. So Caltrans has preserved those old bridges and has redone the pavement, has redone the landscaping in a manner that's consistent with the original landscaping, and it's very much something that people should be proud of. Another case study that might work, and I hope it will work, is an effort to reopen the old Northwest Pacific in Sonoma and Marin County. It's called the Sonoma Marin, whatever the rapid transit is. Rapid transit is going to be primarily a passenger line, but they will also run freight trains on it. And it is a system that has only been out of use for 10 or 20 years, and it's possible that there still are a lot of remnants of the old Northwest Pacific. The depots are principally in place, and the bridges are mostly in place too. So while most assuredly they will build a modern system with concrete ties, welded rails, and so forth, I hope that they will be able to preserve the feel and the function of that old line. So that's about all that I have to say about transportation systems, and I will say thank you.
Thanks, Steve. I'm going to talk more specifically about manufacturing resources and focusing on Southern California. So more specifically, I'm going to speak about identifying manufacturing resources through field survey and through the multiple property documentation approach to field survey and evaluating historic resources. And this is based largely on an approach recommended by the National Park Service as a framework for evaluating the eligibility of thematic groups of historic resources for designation as federal, state, or local historic resources. So the multiple property documentation approach organizes evaluations into historic contexts and then defines property types which represent those contexts. So it facilitates an evaluation because it allows individual properties to be compared with resources that share similar physical characteristics and historic associations. So the majority of these property types are based on the development of the industrial context for the city of Los Angeles, which was completed through Survey LA, which is a citywide survey of historic resources in Los Angeles, managed by the Office of Historic Resources. And Shuttle worked on the development of this context in association with LSA Associates. So there really are an abundance of potential industrial manufacturing resources in Los Angeles, really from the 20th century. The Los Angeles Chamber of Commerce was really instrumental in the early 20th century in developing the manufacturing sector in Los Angeles and really served as kind of civic boosters for the development of transportation, for the development of the port, and a favorable tax policy that was designed to entice Eastern and Midwestern manufacturers to open factories in Los Angeles. So as a result, by 1929, Los Angeles actually had the largest manufacturing output of any city in the western United States and ranked 5th nationally for its manufacturing output. And major industries included automobile manufacturing, aviation and aerospace, textiles, paper goods, some electronics as well, which is why the multiple property documentation approach works for this kind of abundance of potential resources, because it can categorize industrial properties into property types based on their use and manufacturers, and also based on their architecture. So in terms of property types related to manufacturing uses, there are two basic factory property type uses, and that's generic single-story workshops, where a succession of small industrial manufacturers would come in, bring their own tools and machinery, and kind of transform their own rentable workshops. These are usually concentrated in industrial districts along freight rail corridors. And a good example of this is the Goodyear tract in South Los Angeles, which was an industrial tract located next to the Goodyear Tire Company factory, and really served as part of the supply chain for this major tire manufacturer and the automobile industry, with small workshops for plastics, paint, radio. And the second factory type is when a successful small manufacturer moved up in the world and upgraded to a custom-built facility, generally incorporating some aspect of the brand's identity into signs, decorative motifs, even kind of a programmatic ornamentation. So on the left, that's the Van de Kamp's bakery with this kind of Dutch-inspired roof line. And also the sign on the Weber bread is another example. And all of these examples are in the city of Los Angeles, unless I let you know otherwise. And then based on the architectural property type, there are factories that have this kind of applied decoration or an architectural design that relates to the brand. I think Steve called the LAX theme building a marketing building. That's a very similar idea to what these sorts of factories were. The Hoffman Candy Building on the left with this applied Art Deco decoration, or the Coca-Cola bottling plant, a streamlined, modern design, kind of deliberately connecting the company and the brand with this idea of modernity and efficiency through the streamlined, modern architectural style. And then there are property types that are related to a particularly innovative industrial design or engineering type. And it's architecture that's intended to improve the manufacturing process. So there's the daylight factory with industrial steel sash used to increase the amount of glazing and natural light to improve the manufacturing process. That's an example of a pipe factory with this industrial steel sash on the left. And then the former Westinghouse building, now actually loft conversion, is a type of industrial loft with this vertical manufacturing process with the heavy machinery concentrated on the lower floors, lighter processes on the upper floors, and all of the handwork and kind of detailed tasks where the daylight was available. And because industrial buildings had to respond to really unique conditions of manufacturing, things like adequate lighting, ventilation, fire resistance, reducing vibration and noise, and efficient workflows, you can frequently see the manufacturing process expressed through the architecture. So this California Walnut Growers Association is a good example. The California Walnut Growers Association was a cooperative association like Suncrest Growers for citrus that incorporated in 1912 to manage the production of individual walnut growers in California who all became stakeholders in this association. So it combined walnut crops and distributed them under a single brand to reduce competition and stabilize prices for this cash crop. So by 1921, the California Walnut Growers Association controlled more than 50% of the total walnut production in California and built this headquarters and packing facility to accommodate that magnitude of walnut production. This building was designed by architect Albert C. Martin. It has 90,000 square feet, and at its height, it accommodated about 700 workers. And the storing and packing uses of the building are really expressed in the elevations. So the upper floors have these narrow slit windows, and all of the upper floors were used for storage of walnuts. Because walnuts have a fairly high fat content, they're actually fairly perishable even when they're unshelled. And they last much longer if they're stored in a cool, dark place. So the upper floors were purpose-built for this storage of walnuts, which would then travel down the building through gravity conveyors to this third floor with these expanses of glass, which contained all of the cracking and sorting operations for the packing house. So the detail work of picking out the good walnuts from the bad that required the most lighting were contained in these spaces with the sawtooth roof and skylights to provide the most natural light. And then finally, beginning just really in the 1930s, the development of the closed conditions factory with the development of improved lighting and ventilation. Factories began to be built that controlled lighting and ventilation through closed systems for climate control. So really minimal use of windows really only in the office spaces, and all of the manufacturing would have a closed system. This is the Dr. Pepper bottling works, an early example of this kind of controlled conditions factory, built in 1940. So after that overview of property types associated with manufacturing, I wanted to talk more specifically about a detailed evaluation of a single resource. And what are the ways that an understanding of the history of the manufacturing process and a more fine-grained examination of the development of the site over time, how can that inform an evaluation of eligibility of a particular resource and preservation planning for the future. This is the Anaconda Wire Company. It's located in the city of Orange in Orange County, California. Located on a full block site bounded by 3 streets and a railroad to the west. And the site began as a citrus packing house and lumber mill, and then was purchased by the California Wire and Cable Company in 1921, and purchased to be a factory producing outdoor weatherproof wire for utility companies. And this was the first electric wire company west of the Mississippi on this site. So the California Wire and Cable Company actually used an existing building at the corner of the site, essentially here, and then began adding on to the existing building to accommodate this manufacture of wire. So it was a 1-story horizontal manufacturing process with copper wire moving through different sectors of the building based on the stages of the manufacturing process. So by 1930, the California Wire and Cable Company was doing about $3 million in sales annually. And the company was purchased by Anaconda Wire and Cable Company, which was a subsidiary of Anaconda Copper, which owned copper mines throughout the world, was one of the largest companies in the U.S. producing wire products used for public utilities, railroads, radio. And this factory was intended to be Anaconda's first on the West Coast and to serve as headquarters for the West Coast expansion of the Anaconda Wire Company. So during World War II, the company had many large military contracts. It was considered an essential industry for the war effort because wire was used to facilitate combat communications. So during World War II and the scaling up to the war effort, the factory was operating 24 hours a day in 3 shifts with as many as 300 workers. And this volume of production continued in the 1950s with large customers, including Pacific Gas and Electric, but really began to decline in the 1960s, and the factory was closed by 1982 and is now used for a variety of storage uses, essentially. So this is the site today. You can see a full block bounded by the railroad. So part of our evaluation was preparing a series of site plans showing the development of the factory over time to really assist in understanding what the significant spaces of the factory were. So the site developed around this rail spur that entered from the north. This blue section of the building is the oldest section, dating from the California Wire and Cable Company from 1921. The California Wire and Cable Company made some additions to the building, these green sections, and then Anaconda Wire, as part of the development of the site during World War II increased the footprint of the building to these pink sections, and then finally in the 1950s increased the footprint to include this whole yellow section. So part of our evaluation was also understanding what the manufacturing sectors were as the site developed over time. So this portion of the building served as wax coating as kind of a finish process. Again, here's the rail spur where the copper would enter from the railroad and then be stored in this section. I'm just going to run through quickly what the different sectors of the building were. This was the spooling and braiding department. Again, the oldest part of the building at the corner of the site, 1921. This is the interior elevation. The rail spur would have run right here through the site. And this is an interior view of that section B, the wax coating facility. You can see the visible truss system and the roof monitor, and really a large open space to accommodate the wire manufacturing process. Section C, again, was developed in the 1940s for that ramp up to World War II. This barrel roof and a cooling tower. The factory had an elaborate system of tanks and coolant to cool the hot wire as it was drawn through the machines to produce different thicknesses of wire. Section D is connected on the interior with Section C, but was developed in the 1950s, an expansion of the wire mill and cooling processes. And then this is the building as it was developed in the 1950s. You can see much smaller windows, less of an emphasis on daylighting in this newer section of the building, closer to a controlled conditions facility. So as part of our understanding of the development site and the manufacturing process, it's really used to help us understand what the significant spaces of the building were. And we created a three-tiered classification system looking at the primary significance, that is the spaces that are essential to convey the property's historic use and its original physical character. Secondary significance, the space that contributes to the historic character and retains a moderate degree of integrity in that character. And then tertiary, which minimally contributes to the historic context and retains a lower degree of original physical character. This building is actually listed in the National Register as a contributor to the Old Town Orange Historic District, which is significant for the development of the city of Orange from an agricultural community to a small town, and as an intact collection of early Southern California residential, commercial, and industrial buildings. So it's really the earliest development of the factory that's significant based on this context related to the development of Old Town Orange, which is why we considered this oldest section of the building at the corner the 1921 section to be of primary significance. And then a secondary significance of the building is its association with the World War II war industry. So that includes the green sections of the building, which were really developed as part of that ramp up to World War II. And we also considered the remnants of the rail spur, which were important for the development of the footprint of the building to be of secondary significance. And then of tertiary significance, kind of minimally contributing, were the remainder of the 1950s portion of the building. And this was really intended to help with future development of the site, to give the site owner a bit more flexibility in development while still retaining the important character-defining features of the building, including the open floor plan, the south and east facades, the oldest part of the building, the remnants of the rail spur, the fenestration, and the roof assembly, that monitor roof, the skylights, and any structural framing elements. So thank you. I think Jennifer is going to handle the questions.
Yes, so at this time, if you have any questions, please go ahead and type them into the box, and we would be happy to answer them. You can state which speaker that you would like to answer it, or I'll ask them of the entire group. While we're waiting for questions, I'll just ask the group if anybody had any other thoughts or something they would like to, additional thoughts that they would like to share with our participants today. No? Okay. I'm still waiting for some questions.
That noise in the background is not an industrial process. It's the banging pipes in my office.
All right, I am not seeing any questions. Oh, there we go. The first question is, can you put up the slide with the bibliography from the first presentation? And I would be happy to do that. And it should be in your handouts as well, which I will resend with the full slides after the presentation today. You'll also receive more information in regards to our survey and things like that later today. Well, I'm going to that slide on resources. Another question that came up is, can speakers point to any case studies and or scholarship related to energy production, such as petroleum or coal production or oil refining?
Oh boy. I'm sure there are. Right off the top of my head, I know that down in Bakersfield, there is not in Bakersfield, but the town of Taft. There's a wonderful museum to the oil industry that's sort of right in the middle of all oil wells everywhere, and there's a beautiful oil museum in the town of, it's in Ventura County. Oh, Marissa, you can help me with it. It's Santa Paula.
Oh, right.
I'm sure that there's an SIA member who's working on some oil stuff in California. His name escapes me at the moment, but if any of you wish to follow up with an email, I'd be happy to dredge that information out. There's a lot of published stuff in general on, maybe not on California, but in general on coal and oil, and some fantastic sites in the eastern U.S. That can easily be visited.
All right, the next question is, can you speak to dealing with industrial waste and hazardous materials?
Oh, yeah.
Very carefully, I think, is the answer.
Well, there's a nice book. It was aimed at archaeologists, and I'm blanking out on the title, that included some odds and ends about this problem. But there also have been, there was an article published in IA, the Journal of the Society for Industrial Archaeology, about waste, not from a practical standpoint about what kind of hazmat suits to use, but rather ways of identifying particular wastes beforehand. And again, if you follow up with an email to me, I'd be happy to dredge up some titles for you. But yes, it has been handled both from an intellectual point of view and from a safety point of view.
Okay, next question. Given the nature of transportation resources being replaced, how do you evaluate integrity?
Well, I guess that kind of fits my talk. I think that there is a little bit of a sliding scale in the sense that with bridges, they were built so well to begin with, and there are so many of them around that retain really a very good degree of integrity. I think that there are something along the order of 300 are listed in the National Register in California. So your expectations for integrity for bridges, and the same is true with railroad depots. Essentially, I would hazard a guess that almost every existing older railroad depot in California has been listed in the National Register and has been preserved by some sort of local group. So the expectation for those two types of resources is you can set the bar higher. If you're thinking about what do you expect for the integrity of a railroad line, or the lesser sort of bridges like timber trestles, there's so few of them around. And I can't remember the exact phrase, but the National Register criteria do provide some degree of forgiveness in terms of integrity if it is a very rare resource. And most of the aspects of transportation systems, there are so few of them that retain any integrity at all, that if you found an actual railroad line that where the timber trestles and even some of the ties were in place, well, that's a pretty rare duck. So it's kind of a sliding scale depending upon the type of resource that you're dealing with.
All right. The next question is, can you discuss concept continuity of use in hydroelectric facilities and the preservation of historic character, especially the automation, upgrades, and preservation?
Well, I actually have worked with some hydro systems, and there are some. California is a museum of working old hydro systems, and there are very intact generators and very intact primary. What is it? The moving parts, the Pelton wheels that are in good shape. But you know, the expectation is that a lot of the other control systems are going to have to be upgraded, and I don't think you'll find an older hydro system that hasn't been upgraded in that regard. But I think that the prime movers and the generators, you know, there are still some around that have a remarkable degree of integrity, all throughout the Sierra and in Southern California as well.
I can speak a little bit to this as well. The SIA published an entire theme issue on Western hydro plants.
Cool.
10, 15 years ago maybe. I can't easily put my finger at the moment sitting still at my desk on the title, but once again, if you follow up, I'd be happy to get it for you. Second, TICI, the international group that I represent, has internal thematic sections, groups, interest groups that work together, and we have a very active section on hydroelectric plants. That's, in fact, working on an international context theme study for ICOMOS on hydro plants that won't be available immediately, but it's a group that I could put you in touch with that represents an incredible array of expertise on these technical monuments.
Well, that's very interesting, Pat. I'm going to write you about that.
Okay.
Just to follow up, there was a request just to follow up with the one in dealing with hazardous materials and waste, being more specific to the archaeological field work. Just to follow up with you, Pat, is that what that article was about, was in the field and dealing with those?
There's one, and I shut off my mic and scanned shelves here for a minute. I didn't find the volume that I'm looking for. There's one specifically that deals with safety, dealing with buried remains that are nasty. The others are more about using things like slag and tailings to read a site, to understand processes and often date things. And the particular examples from that are some copper mining stuff in Montana, particularly near Butte, and some gold mining in Alaska in the Wrangell-St. Elias National Park, outside of Kennecott, outside of the copper producing area of Kennecott. But again, I just can't put my finger on it at the moment.
Okay. Another question is, other than remote sensing and robotic photography, are there other non-invasive field data retrieval techniques that are helpful to industrial archaeologists?
Oh boy. Yeah, but it's much the same array of stuff that gets used in other archaeological contexts. So at the West Point Foundry, for instance, we use not only radar, but we used magnetometry and we used resistivity. In some instances, simple things like soil resistivity were useful. We made some experiments with infrared photography, looking for different reflectance, and that didn't work very well in that particular setting. Gosh, I'm drawing a blank at the moment, but basically the same array of stuff that's used in other kinds of archaeological contexts.
All right. What types of mapping software do you advise other than GIS for data analysis and interpretation?
Well, what day of the week is it? Basically, we're fighting this issue constantly. I can't tell you how many times we've upgraded the particular systems that we use, from EasyServe to CAD to ArcView, ArcGIS, you name it. Stay as close as you can to the cutting edge of what's being used by surveyors without spending too much money, frankly. We use, because lots of our work is done at a landscape scale in big areas, we do an awful lot of work with GPS. And I have constant arm wrestling matches with my graduate students on whether we're going to use Trimble or we're going to use Archer, and whether we need ArcPad, and whether the client wants output in this format or that format. I have a hard time specifying one system, frankly.
Okay. For Marissa, how does the tiered significance of the Anaconda building relate to CEQA thresholds, for example, material impairment?
Well, there's no project yet. So it would depend on what the current owner would like to do with the building. It's not certain yet that the tertiary areas of significance would necessarily be demolished or even greatly impacted. What we wanted to do was lay out a list of the most significant character-defining features so that the owner can begin to think about what the potential for development is at the site.
Another question is, the issue of integrity of manufacturing buildings is also difficult given that they are often changed in relation to economic and technological changes. Do you give more leeway for evaluating integrity of historic manufacturing buildings?
And I think yes, in general. Certainly we don't expect to see a great deal of the machinery still in place. I'm thinking particularly about the Walnut Growers Association building. The gravity conveyors, which were a big part of the manufacturing and packing process, were no longer in the building. But the windows were intact, the mass and scale of the building was intact. So those things have kind of a greater weight than the specifics of the manufacturing process for integrity.
Yeah, I think that goes back to that picture that Pat showed nearly at the beginning of his talk of that beautiful Ford plant in Richmond, California. It doesn't have any of its industrial machinery still in it, but is it a building that's worth preserving? I'd say absolutely it is. Is it a building that's worth reusing? Absolutely it is, particularly because it's in a whole industrial sector there where you do sort of understand it in relationship to all the other buildings that are around there.
Right, and it still reads as an industrial facility, looking at it from the street.
Mm-hmm.
All right, then next question is, can you give an example of how oral history and ethnography has helped understand industrial complexes?
Yes. One of the particular projects that we worked on in Alaska in recent years is again in the Wrangell St. Elias National Park, an area where there was some gold mining in a particular cluster of gold mining in the 1930s, where there were some survivors of late stages of operations that could be interviewed and explained an awful lot of what we saw on the ground in ways that were very difficult to understand otherwise. It's not always, at least in my experience, most of the stuff that I work on is older than that. So we're a couple of generations removed from having active participants around. But we're using oral history also in a current project in Alaska for the Bureau of Land Management, where we're surveying abandoned gold mines over a large area north of Fairbanks. And there are a lot of old-timers around who are, some of whom have actually been tape recorded as part of a big oral history project. And we can actually get to their stuff even after their deaths. And they provide some very good insights.
I guess one thing I just throw in from the transportation standpoint was just in the last year the Golden Gate Bridge in San Francisco had its 75th birthday, and everybody thinks of the bridge as really almost like a giant sculpture, or it's appreciated primarily for how beautiful it is. But the California Historical Society had a series of interviews and displaying, you know, the work boots and the equipment of the guys who actually built it, and it was absolutely fascinating that the public got to understand a whole new dimension to that incredible piece of sculpture to say that, well, it didn't just get built. It took some pretty gutsy guys and some very big machines, et cetera, et cetera. It was quite an industrial process to build that damn thing.
All right. Well, one more question is, has Caltrans ever determined how the state historic building code applies to historic roads?
Well, yes and no. Caltrans, there is a brand new document that I just put my hands on yesterday, as a matter of fact, that it was not Caltrans, but it was an organization that Caltrans is a part of, which is a Transportation Research Board. And they, in January 2012, put out a document that's called the Design and Management of Historic Roads, and it's a fantastic little document about how you can manage a historic a road like, let's just say, the Arroyo Seco, and retain its historic integrity while having a perfectly safe highway out there. So it's you can look it up. It's called Transportation Research Board Design and Management of Historic Roads. It's not something that Caltrans has done themselves. And I actually am working with Caltrans to try to develop some design guidelines for. They have designated, I believe it is 6 highways around the state, stretches of highways. There's the stretch of Highway 1 through the Big Sur, the Arroyo Seco, a stretch of the Cabrillo Highway in San Diego, Highway 70 going over through the Feather River Pass, and then there's one more. So they're actually taking ownership of the history of their own agency, and they're going out and developing guidelines for each of those highways. They wanted to have sort of one size fits all. I said, you can't do that. They're very different. What works for the Arroyo Seco in Pasadena does not work for the Big Sur Highway in Big Sur. But I would really strongly recommend this relatively new, it's only a few months old, TRB document.
All right, we have time for one more question, and that question is, have any of the speakers used laser scanning to record or document architectural resources to supplement requirements of HAB's hair documentation?
We're doing it right now. In complex sites. I can't say that we've had a completely unvarnished success because the data management is so crazy, but we're actively doing it in conjunction with some people from HARE.
All right. Well, thank you all for joining us today. At the end of this presentation and tomorrow, you'll receive an email with a link to a survey. We would appreciate any feedback on this webinar as well as recommendations for future topics. This is our last webinar of 2012, and we thank you for participating and invite you to look at our website for the 2013 program that will be be posted soon. And we hope that you have a good rest of the afternoon, and thank you again to our speakers today.
Well, thank you.
Thank you.
Thanks.
Thanks.
Bye-bye.
Also that if you're interested in graduate work in this field, Michigan Tech has the only program in North America.
Good to know, and I will send in that email a copy of this webinar today, as well as the contact information for our speakers. All right, thank you.
Bye-bye.
Bye.
Bye.